Hey guys, so now we are going into an inequality. Okay, this one we cannot graph. No, no, no. We cannot graph this one. Okay, but I mean, we could in a way graph it just to see the slope of the line and all that and the y-intercept. We could graph it as if it was a normal equation. So how do I do that? First of all, I have to, guys, I'm sorry, there's no way around it. You have to isolate y in this case, okay? Now, there's just certain little things I want you to remember. When you multiply or divide by a negative, when you multiply or divide by a negative, the sign will flip. The original inequality sign will flip. So, okay, I'm going to isolate y. So I'm going to add 4x to both sides. Okay. Now I have negative y is less than or equal to negative 6 plus 4x. Okay, now I am going to get rid of this negative sign. Okay, here's where it gets a little weird, but it's okay. I think you guys can do this. So we can see it as a negative y as negative 1 times a positive y. And so I would have to basically divide this whole thing by negative 1. Okay? So y becomes isolated, right? But because I divided by a negative, this is a case where my sign flips. So all of this becomes opposite because a negative times a negative, it becomes a positive, but a positive times a negative becomes a negative. So basically, I'm just going to do the opposite of everything I see. So negative 6 divided by negative 1 is positive 6. Positive 4x times negative 1, or divided by negative 1, is negative 4x. So when you're removing the sign on one side to apply to the other side when you're doing inverse operations, that's considered a division of a negative. So in this case, your sign flips, okay? Okay, now this is much better for us to identify the y-intercept and the slope and all that. So you can definitely graph it if you want to, as y is equals to 6 minus 4x, but that's not really going to help as much. It'll help with the slope and it'll help with the y-intercept, but it will not help you with identifying what kind of line this is going to have. Okay, when a symbol is or equal to with the little line at the bottom, this part right here, that means you will have a solid line. So I can eliminate things just because I know it's going to be a solid graph. Like this dotted graph is eliminated. No, because that's a dotted graph. This one too. No dotted graphs. I want a solid graph, solid line graph. So it's between B and D. Now next, what I have to understand is that I have a negative slope. Okay, so this is where maybe your calculator could help you. So let me go into a new graph. So I'm gonna graph it as if it were an equation. Y is equal to, I'm gonna put, see this? I'm gonna put right here 6 minus 4x. And you see that? Y is equal to 6 minus 4x gave me a negative slope. So in other words, it has to be B. It cannot be D because this has a positive slope. This is correct because it has a solid line. Also, it is a negative slope. Also, the shading is correct too because remember what I tell you guys to focus on the y-intercept? If my symbol is greater than or equal to, that means that I'm going to shade all of the area that's more or greater than my y value. So if I'm shading all of this, that means I'm shading all of that, right? This is an example of a less than. See where my 6 is at here? Everything that's less than -6 was shaded. Here is an example of a less than also, because everything that's less than 6 was shaded. This is an example of a greater than, because this one is a greater than, because anything above the 6 was shaded, okay? So don't think of it as, oh, it's greater than means that means it needs to be shaded on the right. That's wrong, or left. No. One kid said, think of this as an arrow, miss. I'm like, no, that is incorrect. You have to look based off of your y-intercept. If it's greater than, that means all values greater than your y-intercept will be shaded. Okay?